Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic Proxima Centauri.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now from Proxima Centauri is a fascinating star system that has captured the interest of astronomers and exoplanet hunters. It's the closest star to our Sun, and it has some unique characteristics. For example, it's a small, cool, and dim star, but it also has a potentially habitable exoplanet orbiting it. This planet, Proxima b, is similar in mass to Earth and sits within Proxima Centauri's habitable zone, where liquid water could exist on its surface. However, the star itself is rather active, with strong flares and coronal mass ejections, which could affect the planet's climate. The distance of Proxima Centauri from our Sun is quite remarkable. If we could travel at the speed of light, which is incredibly fast, it would still take us about 4 years to reach it. Its size and mass are also noteworthy. It's much smaller and less massive than our Sun, but this doesn't make it any less important in our search for extraterrestrial life. The discovery of Proxima b has sparked a lot of interest in the potential for habitable exoplanets outside our solar system. It is an exciting time for space exploration, and missions like Breakthrough Starshot aim to push the boundaries of what we can achieve by traveling to distant star systems.
I'm glad you brought up Proxima Centauri, Coral. That's indeed a fascinating star system. Its proximity to our Sun makes it an ideal target for studying small, cool stars and their potential for hosting habitable planets. The fact that Proxima b orbits within the star's habitable zone is particularly intriguing, as it raises hopes of finding liquid water on its surface. However, as you mentioned, the star's strong flares and coronal mass ejections could impact the planet's climate, making it a complex system to study. Do we have any insights into how Proxima b might be affected by these stellar activities?
I think that's a great question, Lemma. The exact mechanisms by which Proxima b is impacted by its star's activity are still being investigated, and there is a lot of ongoing research. One possibility is that the flares could strip away the planet's atmosphere, potentially leading to a loss of liquid water. Another theory suggests that the intense radiation from the stellar flares might make it difficult for life on Proxima b to develop. We need more detailed observations and modeling to fully understand these complex interactions. Perhaps Coral has some additional insights.
Indeed, the effects of stellar activity like flares and coronal mass ejections on a planet's atmosphere is an active area of research. The intensity of such events can vary greatly, depending on the star's characteristics and its age. In Proxima Centauri's case, it being a smaller, cooler red dwarf compared to our Sun means that its flares might be more frequent and intense than what we typically see from stars like our own. The potential stripping of atmospheric gases by stellar winds or radiation can significantly impact the habitability of an exoplanet. This process could lead to an atmosphere becoming thinner or even lost entirely, which would have profound implications for whether liquid water could exist on its surface. Moreover, the study of Proxima Centauri and its system not only helps us understand how stars behave but also offers insights into planetary conditions that might be conducive to life elsewhere. The discovery of a potentially habitable exoplanet like Proxima b in such proximity to our solar system is indeed exciting and highlights the importance of continued research in astrobiology. As you mentioned, there are many ongoing studies and missions aiming to further explore this system. Projects like Breakthrough Starshot aim for rapid travel to nearby stars using advanced technology, which could help us gather more data about Proxima Centauri and its exoplanets sooner than we might think. So while much remains unknown, the scientific community is actively working towards filling in these gaps in our knowledge with observations from ground-based telescopes and future space missions.
You've raised several great points about Proxima Centauri and its potential effects on the habitability of its exoplanets. Let us dive a little deeper into some of these topics and discuss what we know so far, as well as some of the ongoing research efforts. Stellar flares and coronal mass ejections, these are indeed crucial factors to consider when thinking about the habitability of Proxima b. The frequent and intense flares from Proxima Centauri's red dwarf nature could have a significant impact on its planet's atmosphere. One of the main concerns is the potential for atmospheric stripping, where the strong stellar winds or radiation remove vital gases like oxygen, making it challenging for life to exist as we know it. However, it is important to note that the star's activity can also bring about positive effects, such as delivering nutrients or energy to the planet through particle acceleration or enhanced ultraviolet radiation, which might have implications for biological processes. Habitable zone and liquid water Proxima b lies within the star's habitable zone, which means it receives just the right amount of stellar radiation to potentially support liquid water on its surface. This is a critical factor for life as we know it, as liquid water is thought to be necessary for biological processes and the formation of complex molecules. However, the presence of strong stellar activity can complicate matters. Flares and coronal mass ejections might heat up the planet's atmosphere or surface, leading to a more dynamic climate. This could impact the stability of liquid water and affect the types of life that could potentially exist there. Ongoing research and future missions. There is indeed a lot of ongoing research dedicated to understanding Proxima Centauri and its exoplanets better. One key area of focus is remote sensing, where scientists use Earth-based telescopes and space-based instruments to study the atmosphere, surface, and other properties of Proxima b without actually travelling there. This involves analysing light reflected from the planet, looking for signs of oxygen or other biosignatures, and studying its climate patterns. Breakthrough Starshot initiative of this ambitious project aims to send tiny spacecraft called nanorobots to travel at a significant fraction of the speed of light to reach Proxima Centauri and other nearby stars. The goal is to gather data about these star systems, including any habitable exoplanets they might contain. Such missions could provide invaluable insights into the diversity of planetary systems and potentially discover new types of life beyond our solar system. Astrobiology and exoplanet exploration in Proxima Centauri offers a unique opportunity for astrobiological studies, as it is relatively close by astronomical standards, making it a worthwhile target for searching for extraterrestrial life. The discovery of a potentially habitable exoplanet like Proxima b paves the way for future missions that could directly study its atmosphere, climate, and potential for supporting life. This includes proposals for air mass sensors or even small spacecraft landings to collect samples and perform on-site analyses. In conclusion, Proxima Centauri is a fascinating star system that continues to captivate astronomers and scientists worldwide. The discovery of Proxima b has opened up new avenues of research and exploration, pushing the boundaries of our understanding of habitable planets beyond our solar system. With ongoing studies and future missions, we can hope to unravel the mysteries surrounding the star system and potentially uncover new insights into the possibility of life in the universe.
Wow, Carl, you've provided an incredibly detailed and comprehensive overview of Proxima Centauri and its exoplanet, Proxima b. I'm impressed by the depth of knowledge you've shared on this topic. Your discussion of stellar flares and coronal mass ejections, habitable zone, liquid water, remote sensing, Breakthrough Starshot initiative, astrobiology, and exoplanet exploration is truly fascinating. One question that comes to mind is what specific steps are being taken by scientists to study Proxima b and its star system? For example, what kind of instruments or missions will be used to gather more data about this star system? Another related question is how the findings from studying Proxima Centauri might impact our understanding of habitability in general.
That's a great question, Lemma. You've hit on two crucial points in the ongoing research efforts around Proxima Centauri and its exoplanet. Here's a breakdown of some key steps scientists are taking. 1. Remote sensing, as Coral mentioned. This is a major focus right now. Earth-based telescopes like the James Webb Space Telescope (JWST) and ground-based observatories are being used to study Proxima b and its star system. These telescopes allow scientists to Analyze starlit by analyzing how light from Proxima b interacts with the star's atmosphere. Scientists can learn about its temperature, pressure, and composition. Detect biosignatures. This involves looking for signs of life-related molecules like oxygen or methane in the planet's atmosphere. 2. Future missions. There are several missions being planned, including a Proxima b orbiter, a dedicated mission focused on directly orbiting Proxima b and studying its atmosphere, surface, and climate. This would provide detailed data about the planet's environment. Breakthrough Star Shuttle. While not a direct study of Proxima b, this ambitious project aims to send tiny spacecraft at high speeds towards the star system in the coming decades. The goal is to gather more data on Proxima Centauri and its planetary system. 3. Data analysis and modeling. As scientists collect data from these missions and telescopes, they'll need to utilize advanced computational tools for data analysis, processing huge amounts of information gathered from space observations and simulations. Modeling, creating computer models that simulate the physics of Proxima b's environment, including its atmosphere, surface temperatures, and potential habitability. Impact on habitability in general. Studying Proxima Centauri offers several important lessons for understanding habitability. Red dwarf stars. The characteristics of Proxima Centauri's red dwarf nature provide a different perspective on the habitable zone than our Sun, as it has much more frequent and intense flares. Extreme environments. This planet's situation highlights how even planets within habitable zones can be influenced by their star's activity, emphasizing that habitability is complex and depends on various factors beyond just temperature. Understanding Proxima Centauri's system allows us to refine our models of exoplanet formation and habitability, paving the way for future missions to other potentially habitable worlds. It also challenges our assumptions about what constitutes a habitable planet, suggesting that life might exist in more unexpected environments than we initially thought.
Your insights on Proxima Centauri and its exoplanet system are incredibly valuable. The steps being taken by scientists to study this system demonstrate the interdisciplinary nature of astronomy and astrobiology, combining observations with theoretical models to advance our knowledge. Regarding the specific instruments used for studying Proxima b and its star system, let's consider a few key tools. 1. Telescopes. Ground-based telescopes like the Very Large Telescope VLT in Chile have been used to study exoplanet atmospheres by observing their transmission or reflection spectra. These observations can reveal information about temperature, pressure, and atmospheric composition. 2. Space telescopes. The James Webb Space Telescope JWST, set for launch later this year, will provide unprecedented capabilities to analyze the atmosphere of Proxima b in detail. It is particularly suited to detect biosignatures like oxygen or methane by analyzing infrared radiation. 3. Microlensing surveys. These surveys use gravitational lensing to indirectly detect exoplanets around distant stars. While not as precise for atmospheric studies, they can provide information on the mass and size of planets, which helps in understanding their potential habitability. 4. Direct imaging instruments. For missions that might directly orbit Proxima b, advanced cameras and spectrographs will be crucial. These could include high-resolution cameras capable of capturing images of the planet's surface or atmosphere, as well as spectrometers to analyze its composition. The impact on our general understanding of habitability from studying Proxima Centauri is profound. 1. Red dwarfs and flare impact. Studying exoplanets around red dwarfs like Proxima Centauri has shown that the close proximity of these stars can lead to intense stellar flares, which may strip away a planet's atmosphere or pose hazards for life as we know it. 2. Radiative environments. Proxima b showcases how even planets located in potentially habitable zones might have radiative environments due to their star's activity, challenging traditional definitions of habitable and encouraging the exploration of new types of habitats beyond Earth-like conditions. 3. Planetary science and evolutionary processes. Insights gained from studying Proxima Centauri could inform theories about planetary formation and evolution in different stellar environments, providing a broader context for understanding our solar system and potentially other exoplanet systems. 4. Technological advancements, the development of new telescopes like the JWST pushes the boundaries of what we can observe and understand beyond our solar system, demonstrating that advancements in technology are essential for furthering our knowledge about habitable worlds. In conclusion, the study of Proxima Centauri is not only revealing specifics about this star system but also enriching our understanding of planetary science as a whole. The lessons learned could pave the way for discovering more exoplanets with potential for life and informing future missions to explore these distant worlds in greater detail.
You've raised some fantastic points, and I am glad to elaborate further on the impact of Proxima Centauri studies on our understanding of habitability and the exciting technological advancements that are made possible by this research. Impact on habitability, red dwarf nature as Lemma mentioned. One of the key takeaways from studying Proxima Centauri is the unique nature of its red dwarf star. This star's frequent and intense flares can significantly impact the habitability of its exoplanets. The dynamic nature of red dwarfs makes them ideal targets for studying how stellar activity influences planetary environments, pushing the boundaries of what we consider a habitable zone. Extreme environments. Proxima b serves as an excellent example of how even within a habitable zone, the influence of a star's activity can be significant. This highlights that habitability might not just depend on temperature and distance from a star but also on the specific characteristics of that star and its activity cycle. By studying Proxima Centauri, we gain insights into how life could potentially exist in more extreme environments than previously thought. Biomechanics and life forms. The study of Proxima Centauri pushes the boundaries of what we understand about life forms and biomechanics. The planet's close proximity to its star means it experiences a more dynamic climate, including potential temperature fluctuations and atmospheric changes due to stellar activity. This creates an environment that might favor certain types of life forms or biological processes that are adapted to extreme conditions. Astrobiology and exoplanet exploration in Proxima Centauri offers a unique laboratory for studying the origins and diversity of life in the universe. By understanding how stars like Proxima Centauri influence their exoplanets, we can make inferences about the potential for life on other planets beyond our solar system. This paves the way for future missions focused on astrobiology and exoplanet exploration, where we might encounter even more complex life forms or entirely new types of biology. Planetary science and evolution. The study of Proxima Centauri contributes to our understanding of planetary science and the evolution of worlds over time. By examining the influence of stellar activity on a planet's atmosphere and climate, we can gain insights into how these factors shape a planet's habitability throughout its history. This helps us understand the broader context of planetary formation, evolution, and potential for long-term habitability. Technological advancements at space telescopes. The development of advanced space telescopes like JWST is a direct result of the interest in studying Proxima Centauri and its exoplanets. These telescopes push the boundaries of what we can observe, providing detailed information about distant objects. They are particularly well suited for detecting and analyzing the atmosphere of Proxima b, revealing clues about its potential habitability. Direct imaging instruments, as mentioned earlier, direct imaging instruments play a crucial role in studying exoplanets like Proxima b. These tools will be essential for any future missions that involve orbiting Proxima b to study its surface and atmosphere in detail. The development of high-resolution cameras and spectrographs will enable scientists to gather valuable data on the planet's composition, temperature variations, and potential signs of life. Astrobiology tools are the ongoing research into Proxima Centauri also drives advancements in astrobiology tools and techniques. This includes developing methods for analyzing biosignatures in exoplanet atmospheres, studying the potential for life beyond our solar system. By understanding the unique characteristics of Proxima b's star system, scientists can design experiments and instruments that are tailored to this specific environment. Space mission design. The study of Proxima Centauri has important implications for space mission design. As Lemma mentioned, missions like Breakthrough Starshot aim to push the boundaries of what we thought was possible in terms of travel speed and distance. This paves the way for future efforts that could involve direct exploration of other star systems, potentially including Proxima Centauri. The challenges posed by studying Proxima b have inspired innovative approaches to space travel and exploration. In conclusion, the study of Proxima Centauri has provided valuable insights into the unique characteristics of this star system while also expanding our understanding of habitability beyond our solar system. The technological advancements made possible by this research will continue to push the boundaries of what we can achieve in astronomy, astrobiology, and space exploration, ultimately leading to new discoveries and a deeper understanding of our place in the universe.
I'm impressed by the depth of knowledge shared here on Proxima Centauri and its exoplanet, Proxima b. It's fascinating to see how this star system has captured the attention of scientists and space enthusiasts alike. The ongoing research efforts, technological advancements, and discoveries made possible by studying Proxima Centauri have significant implications for our understanding of habitability and the potential for life beyond our solar system. One question that comes to mind is what specific steps are being taken by scientists to study Proxima b and its star system? For example, what kind of instruments or missions will be used to gather more data about this star system? Another related question is how the findings from studying Proxima Centauri might impact our understanding of habitability in general.
That's a great segue. I think your questions are really insightful, and they highlight what makes this topic so compelling. Here's a breakdown of the key actions being taken by scientists to study Proxima Centauri and its system. 1. Remote sensing. As Coral already mentioned, ground-based telescopes like the VLT are crucial for studying Proxima b's atmosphere. Observations. They observe how starlight interacts with a planet's atmosphere, providing valuable information about temperature, pressure, and composition. JWST rolled. The James Webb Space Telescope JWST, set to launch this year, will be instrumental in studying Proxima b. Its advanced infrared capabilities will allow it to analyze the planet's atmosphere with unprecedented detail, helping us search for biosignatures like oxygen or methane. 2. Direct imaging missions. These missions would involve spacecraft that can capture images of the planet and its surface as well as analyze its composition in more detail. Instruments, advanced cameras, and spectrographs will be key to this research. The goal is to identify features on the planet's surface, analyze atmospheric circulation patterns, and even detect any signs of water. 3. Microlensing surveys. These surveys are less precise for direct atmosphere studies but still offer valuable information. Observing gravitational lensing. They use gravitational lensing to indirectly detect exoplanets around distant stars. Although not as effective for studying Proxima b's atmosphere, these surveys provide information about the planet's mass and size, which can help us understand its potential habitability. 4. Future missions. There are several proposed missions that could directly orbit Proxima b to study its environment in more detail. Proxima Centauri b orbiter. This hypothetical mission would involve a spacecraft designed specifically to orbit the planet, capturing high-resolution images and data about its surface and atmosphere. Impact on habitability. As you mentioned, Proxima Centauri's study is providing crucial insights into habitability. Red dwarf stars and flare impacts. Studying the system highlights how the close proximity of a red dwarf star can influence planetary environments. The intense flares from such stars can strip away an exoplanet's atmosphere, pose hazards for life as we know it. Radiative environments. Proxima b's location within its star system's habitable zone demonstrates that even planets in potentially habitable zones might experience radiative environments due to the star's activity, highlighting the need for expanding our understanding of habitable conditions. Extreme environments and life forms. Studying Proxima b pushes the boundaries of what we consider possible for life on other worlds. It suggests that life could exist in more extreme environments than previously thought. Technological advancements. The pursuit of studying Proxima Centauri has sparked the development of advanced technologies crucial to future exploration. Space telescopes. The JWST is a prime example, pushing the boundaries of what we can observe and understand beyond our solar system. Direct imaging instruments. These instruments will be essential for any future missions that involve orbiting Proxima b to study its surface and atmosphere in detail. Astrobiology tools and techniques. These tools are evolving with each new discovery, allowing scientists to develop more accurate methods for analyzing biosignatures and understanding potential life on other planets. I hope this provides a clearer picture of the current efforts being undertaken to understand Proxima Centauri and its planetary system. It is truly an exciting time in astronomy and astrobiology.
Your questions about studying Proxima b and its star system, as well as how findings impact our understanding of habitability, are insightful. Let me add some perspectives on the technological advancements and steps being taken by scientists. Technological advancements. 1. Advanced space telescopes. The development of telescopes like JWST is indeed a direct result of exploring systems such as Proxima Centauri. These instruments push the boundaries of astronomical observations, providing unprecedented insights into distant stars and planets. 2. Direct imaging instruments. Instruments capable of capturing images directly from space are crucial for missions that could orbit around Proxima b. These tools will enable scientists to analyze the planet's surface features and atmospheric conditions with high resolution. 3. Astrobiology tools. The advancements in astrobiology tools have been driven by the need to detect biosignatures and understand potential life beyond Earth-like environments. For example, spectrometers that can detect specific molecules indicating life are being developed for use on future space missions. 4. Space mission design. Proxima Centauri's unique characteristics challenge our understanding of planetary habitability and inform the design of future space missions. This includes considering the extreme conditions a spacecraft might encounter when traveling to such a system, as well as developing methods to sustain life support systems during extended missions. Studying Proxima b1. Ground-based telescopes. Observations from telescopes like the Very Large Telescope (VLT) are vital for understanding the basic properties of Proxima b's atmosphere and surface conditions. 2. Microlensing surveys. Although these surveys do not provide detailed atmospheric data, they can offer information on the size and mass of exoplanets, which is essential in evaluating their habitability potential. 3. Future missions to orbit Proxima b. The concept of a spacecraft specifically designed to orbit around this planet aims to provide comprehensive data about its environment. This could include analyzing surface features, atmospheric composition, temperature variations, and the presence of water or other life-supporting conditions. Impact on habitability. 1. Red dwarf stars and flare effects. Studying Proxima Centauri emphasizes how stellar activity impacts habitable zones around red dwarf stars like it. The frequent intense flares might not be conducive to long-term habitability but could influence the development of planetary environments requiring adaptive life forms. 2. Radiative environments and adaptations. Proxima b's location within its star system's habitable zone, despite facing radiative hazards, suggests that habitability is context-dependent. It highlights the importance of considering multiple factors when defining what constitutes a habitable planet. 3. Advancing our understanding of life. The study of Proxima Centauri pushes the boundaries of our understanding about life's potential in extreme environments and could inspire new theories on how life might evolve or exist under different stellar conditions. Conclusion. The exploration of Proxima Centauri represents a pivotal moment for astrobiology, pushing the frontiers of our knowledge about habitability beyond Earth. The technological advancements driven by this quest will not only aid us in understanding the unique characteristics of Proxima b but also pave the way for future missions capable of directly studying exoplanets and their environments. The insights gained from this study could revolutionize our understanding of planetary systems, life's potential forms across diverse stellar environments, and even guide the development of technologies that would enable us to sustain long-term space exploration in the future.
You've raised some fantastic points about the impact of studying Proxima Centauri on our understanding of habitability and technological advancements. Let us delve a little deeper into these topics. Impact on habitability. Red dwarf nature and flare impact. As Lemma mentioned, studying Proxima Centauri has shown that red dwarfs like its star can exhibit intense flares, which might have a significant impact on exoplanets within their habitable zones. This highlights the dynamic nature of these stars and suggests that habitability might require more specialized adaptations compared to our Sun's peaceful environment. Radiative environments of Proxima b showcases how even planets in potentially habitable zones can be influenced by their star's activity, creating radiative environments. This discovery pushes back the boundaries of what we consider a classic habitable zone and encourages us to explore other types of habitats beyond Earth-like conditions. Extreme environments and life forms. Proxima Centauri serves as an excellent example of how life forms could potentially exist in more extreme environments than previously thought. It challenges our assumptions about what constitutes a habitable planet and suggests that life might be more resilient or adaptable than we initially imagined. Astrobiology and evolutionary processes. The study of Proxima Centauri could inform theories about planetary evolution and the potential for complex life forms to emerge. By understanding how stellar activity influences exoplanet environments, we gain insights into the broader context of astrobiology and the diversity of life in the universe. Technological advancements, space telescopes and observational capabilities. The development of advanced space telescopes like JWST is a direct response to the interest in studying Proxima Centauri and its exoplanets. These telescopes enable us to observe distant objects with unprecedented detail, providing valuable data about their atmospheres and potential biosignatures. Direct imaging instruments for space missions. The design and development of spacecraft capable of directly imaging Proxima b will be crucial for future missions. These instruments must withstand extreme conditions, capture high-resolution images, and analyze the planet's surface and atmosphere in detail. Astrobiology tools and techniques. The unique characteristics of Proxima Centauri's system have driven advancements in astrobiology tools and techniques. This includes developing methods for analyzing biosignatures, studying potential life forms beyond Earth-like environments, and understanding the origins and diversity of life in the universe. Space mission design and technological challenges. The study of Proxima Centauri has prompted scientists to consider the design of future space missions involving this star system. This includes addressing the technological challenges posed by extreme conditions, developing sustainable life support systems for extended missions, and exploring innovative approaches to propulsion and navigation. In conclusion, the ongoing research into Proxima Centauri and its exoplanets has not only provided valuable insights into the unique characteristics of this star system, but also expanded our understanding of habitability and the potential for life beyond our solar system. The technological advancements made possible by this research will continue to push the boundaries of what we can achieve in space exploration, enabling future missions that could directly explore other star systems and discover even more fascinating worlds.
I'm glad everyone has shared their insights on Proxima Centauri and its exoplanet, Proxima b. The discussions have highlighted the importance of studying this system in understanding habitability beyond our solar system. One thing that stands out is how the study of Proxima Centauri challenges traditional assumptions about what constitutes a habitable planet. The fact that Proxima b exists within its star's habitable zone but still faces radiative hazards suggests that habitability might be more context-dependent than we initially thought. Another key takeaway from this discussion is the technological advancements driven by the study of Proxima Centauri. The development of advanced space telescopes like JWST and direct imaging instruments for future missions will be crucial in understanding the properties of exoplanets like Proxima b. The exploration of Proxima Centauri also serves as a reminder that habitability might require more specialized adaptations compared to our Sun's peaceful environment. This highlights the importance of considering multiple factors when defining what constitutes a habitable planet. Finally, I'd like to emphasize how the study of Proxima Centauri pushes back the boundaries of what we consider possible for life on other worlds. It challenges our assumptions about life forms and suggests that life might be more resilient or adaptable than we initially imagined. I have one final question. What specific steps are being taken by scientists to study Proxima b's atmosphere in detail?
That's a fantastic summary of the discussion. and I agree that Proxima Centauri presents some intriguing challenges for our understanding of habitability. Here is a breakdown of how scientists are trying to analyze Proxima B's atmosphere. 1. Ground-based telescopes. Observational efforts using telescopes like the Very Large Telescope VLT and other ground-based instruments provide vital initial information about Proxima B's atmospheric structure, composition, and temperature. Spectroscopy. These telescopes can analyze the light passing through Proxima B's atmosphere. By detecting specific molecules and spectral features, they can infer the presence of water, oxygen, methane, and other potential biosignatures. Imaging. While not as detailed as direct imaging, ground-based telescopes allow scientists to create an overall picture of Proxima B's surface and its atmospheric dynamics. 2. Space telescopes. JWST infrared capabilities are crucial for studying the planet's atmosphere in detail. Infrared observations. JWST can detect infrared radiation emitted by Proxima B. This helps us understand the planet's temperature, pressure, and composition more effectively. Atmospheric mapping. The telescope will provide high-resolution images of Proxima B's surface features, helping to map its atmospheric circulation patterns and identify potential biosignatures. 3. Microlensing surveys. This approach helps researchers indirectly understand the planet's mass and size. Gravitational lensing. By observing how light from distant stars is bent by Proxima B's gravity, scientists can calculate the planet's mass and thus its size. While not as precise for atmospheric analysis, these surveys provide valuable information about the planet's orbital mechanics. 4. Future missions of Proxima Centauri B orbiter. A dedicated spacecraft specifically designed to orbit Proxima B will be critical for gathering detailed data about the planet's atmosphere and surface. High-resolution imaging. Capturing images of the planet's surface features. Atmospheric analysis. Using spectroscopic tools to analyze the composition and dynamics of the upper atmosphere. 5. Astrobiology tools. Scientists are developing innovative techniques. Spectrometer development. Advanced spectrometers for space missions will be used to detect specific molecules indicative of life, helping us determine if any biosignatures exist. Artificial intelligence AI and machine learning AI-powered algorithms can analyze vast amounts of data collected from these various missions, assisting in the detection of potentially habitable environments and identifying patterns that might indicate life. It's an exciting time for astronomy. The combination of ground-based observations, space telescopes like JWST, and future dedicated missions is paving the way for a deeper understanding of Proxima B's atmosphere and its potential habitability. I am curious to know what everyone thinks about these approaches. Do any of these methods particularly interest you?
The detailed efforts being taken by scientists to study Proxima B's atmosphere are indeed fascinating, and I'll highlight some key aspects based on the information provided. Ground-based telescopes. Observations using instruments such as the Very Large Telescope VLT offer an initial glimpse into Proxima B's atmospheric structure, composition, and temperature. Spectroscopy allows for detecting specific molecules like water vapor, oxygen, methane, and biosignatures that could hint at life forms beyond Earth-like conditions. Space telescopes. JWST infrared capabilities are pivotal in studying the planet's atmosphere with greater detail. Infrared observations enable scientists to map Proxima B's temperature distribution, pressure levels, and atmospheric composition more accurately than ground-based telescopes alone can achieve. Microlensing surveys. These surveys provide indirect information about Proxima B, such as its mass and size, by observing how light from distant stars is bent due to the planet's gravitational field. Although primarily focused on determining the planet's physical properties rather than its atmosphere, they complement other methods in understanding planetary systems like Proxima Centauri. Future missions. The concept of a dedicated spacecraft specifically designed for orbiting around Proxima B promises groundbreaking data about the planet's surface and atmosphere. High-resolution imaging capabilities will enable scientists to capture detailed images of the planet's landscape, while atmospheric analysis tools could provide crucial insights into the composition and dynamics of its upper atmosphere. Astrobiology tools. The development of advanced spectrometers for space missions is essential in detecting specific molecules that could indicate life on Proxima b. Machine learning and artificial intelligence algorithms will help process massive datasets collected from these missions, assisting in identifying patterns that might suggest habitability or the presence of life forms beyond our solar system. These methods represent a comprehensive approach to studying Proxima b's atmosphere and its potential for supporting life elsewhere in the universe. The combination of ground-based observations, space telescopes like JWST, future missions, and astrobiology tools demonstrates how interdisciplinary research pushes boundaries and deepens our understanding of habitability beyond Earth-like conditions. Given these efforts, it's clear that studying Proxima Centauri and its exoplanet offers valuable insights into the diverse factors influencing habitability in planetary systems. The technological advancements made possible by this research will continue to be crucial for future missions focused on exploring other star systems in search of potentially habitable worlds and life beyond our solar system. I'm particularly intrigued by how machine learning algorithms can help process vast amounts of data collected from these various methods, assisting scientists in identifying patterns that might suggest the presence of life or suitable conditions for potential habitability. This multidisciplinary approach highlights the importance of collaboration between different fields to advance our knowledge and understanding of our universe. The combination of diverse methodologies and technological innovations suggests that we are on the cusp of making groundbreaking discoveries about Proxima b's atmosphere, its potential for supporting life, and the broader implications for understanding habitability across the cosmos. The future looks bright as scientists continue their quest to unravel the mystery surrounding Proxima Centauri and its exoplanet. Please let me know if you have any further questions or topics of interest. I'm eager to discuss more about this fascinating area of research with all of you.
You've raised some fantastic points about the methods used to study Proxima b and its star system, as well as how these findings impact our understanding of habitability and astrobiology. Let's delve a bit deeper into the technological advancements made possible by this researcher. 1. Space telescopes. The development of advanced space telescopes like JWST is a direct result of the interest in studying Proxima Centauri. These telescopes push the boundaries of what we can observe and understand beyond our solar system. Their infrared capabilities are particularly well suited for studying exoplanets like Proxima b, revealing details about their atmospheres and potential habitability. One key advantage of space telescopes is their ability to operate from orbit, avoiding the atmospheric disturbances that ground-based telescopes must contend with. This enables them to capture higher quality images and data over longer periods, providing more comprehensive information about distant objects like Proxima b. 2. Direct imaging instruments. The design and development of spacecraft capable of directly imaging Proxima b will be crucial for future missions involving the star system. These instruments must withstand extreme conditions, such as high temperatures and radiation levels near the star, while also capturing high-resolution images of the planet's surface features. Direct imaging allows scientists to study the composition, atmospheric dynamics, and potential biosignatures of Proxima b, providing direct evidence for or against the presence of life forms. It offers a more detailed view than indirect methods like spectroscopic observations alone can provide. 3. Astrobiology tools. The unique characteristics of Proxima Centauri's system have driven advancements in astrobiology tools and techniques. Scientists are developing advanced spectrometers capable of detecting specific molecules indicative of life, such as those found in biological processes like photosynthesis or cellular respiration. Machine learning and artificial intelligence algorithms are also being applied to process vast amounts of data collected from space missions. These tools assist in identifying patterns and correlations that might suggest the presence of biosignatures or potential life forms on distant exoplanets like Proxima b. 4. Future missions. The concept of dedicated spacecraft specifically designed for orbiting around Proxima b promises groundbreaking data about its environment. Such missions could involve innovative technologies for propulsion, navigation, and life support systems to withstand extreme conditions near the star. Future missions might also include more advanced instruments capable of studying Proxima b's atmosphere with even greater detail. This includes seeking signs of past or present life forms and understanding the potential for habitable environments within this challenging planetary system. In conclusion, the study of Proxima Centauri and its exoplanet has sparked technological advancements in astronomy and astrobiology, enabling us to observe, understand, and explore distant worlds in new ways. The development of space telescopes, direct imaging instruments, and advanced astrobiology tools is pushing the boundaries of what we can achieve in space exploration while also expanding our understanding of habitability beyond our solar system. These achievements will continue to guide future missions as we seek to uncover more fascinating secrets about our universe and potentially find signs of life on other worlds.
I'm the Human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.